Good morning students, welcome back. Today we are going to discuss amines as our next chapter, and in amines we will discuss the major preparation reaction and important chemical properties as well as their chemical reaction. Now this is the second last chapter of organic chemistry, so till the time we come to amines, most of the students' energy get exhausted and they don't feel the need to study these chapters in detail. But these are very important chapters. Small questions can definitely come on this chapter as well. So what I would recommend you is, after completing the chapter, just go and read the NCERT and solve the daily practice problem sheet. Okay, so let's get started with the lecture. So today we are going to discuss the preparation of amines. So the first preparation of amines is from alkyl halide. Now this is also called as ammonolysis. Now if you look at this reaction, what happens is ammonia attacks on the Rx, that is an alkyl halide molecule, in a SN2 fashion, and ultimately leads to a formation of a quaternary ammonium salt. Now the next question that comes in the mind, why a quaternary ammonium salt is formed over here? Okay, so if you look at this reaction, what is happening exactly is, first we are taking a Rx molecule, to this we are adding ammonia, right. So this is an example of a SN2 reaction. So nitrogen from its lone pair attack at the carbon bearing the halogen. This halogen leaves as the halide ion. So basically we form a 1 degree amine over here. Okay. Now once a 1 degree amine is formed, we know that a alkyl group has a plus I effect. So what it will do, it will release electron and increase the electron density on nitrogen. Now because the electron density on nitrogen has increased, so its nucleophilic strength will always increase as compared to ammonia. If you look at ammonia and RNH2, because of the plus I effect of R group, the electron density on nitrogen has increased, due to which its nucleophilic strength has increased. So if there is any Rx in the mixture that is left, so this will again go and attack at the carbon bearing the halogen. Halide will leave as a leaving group. So basically we are going to form R, NH, R. So basically we are going to form a 2 degree amine. Now once two alkyl groups are incorporated with a nitrogen, because of their inductive effect, the electron density on the nitrogen further increases. Now because of this increase in electron density, its nucleophilic character again increases. So any RCl which is left in the reaction mixture, it would attack on the alkyl halide or the alkyl chloride, and we would form a 3 degree amine. Okay. Now we know that a 3 degree amine, there are 3 R groups attached to nitrogen, which will further increase the electron density and increases its nucleophilic strength. So this will go and attack at the carbon bearing the halogen, and finally we will form a 4 degree nitrogen or a quaternary ammonium salt. Okay, so in this reaction we are forming a quaternary ammonium salt. Okay, that is what is written, substituted ammonium salt. So we are forming a quaternary ammonium salt. Okay. So in this reaction, it is difficult for us to stop the reaction at 1 degree amine. Like suppose you are taking ammonia and to this you have added Rx, okay, any alkyl halide. Now some portion of ammonia attacks on the alkyl halide and forms RNH2. Once RNH2 is formed, its nucleophilic strength increases, so it will go and attack back at the Rx molecule that was there in the mixture. Hence multiple alkylation occurs in the reaction. So from this process we will not be able to prepare 1 degree amine effectively. So we are not going to prepare. So we will say that this does not help us in preparing 1 degree amines, are not prepared efficiently in this reaction. Okay. So one strategy which we should adopt over here is, one strategy which we should adopt over here is take less amount of Rx and take excess amount of ammonia. Okay? Take less amount of Rx and take excess amount of ammonia. So what will happen, because ammonia is in excess amount, it will go and attack at all the alkyl halide molecules and they would convert into RNH2. Now because no Rx molecule would be left when it is taken in less quantity and ammonia is taken in large quantity, hence the multiple polyalkylation won't occur in this reaction. So that is one way to prepare 1 degree amine through this method. But overall we say that 1 degree amines are difficult to prepare, because once a 1 degree amine is formed, its nucleophilic strength has increased, so it can go and attack at the other alkyl halide molecule and form a 2 degree, further 3 degree and a quaternary ammonium salt. Okay, so I hope this is clear to everyone. One such reaction is also called as transamidation. Okay, so what happens in a transamidation is, we basically replace the amide with another amide group. Okay, so basically this nitrogen is going to attack at the carbon, carbonyl carbon, and it is going to form RCO negative, NHR2, NHR1 is attached at this. So they will push the electron and this will go out. So basically what we are doing, we are replacing the NHR group with another NHR group, and through this we are taking out one of the RNH group, and we say this is called as transamidation. Okay, so I hope these two reactions are clear to you. Okay, the next reaction that comes is Gabriel phthalimide reaction. Now this is a very important reaction. Many questions have been asked on Gabriel phthalimide reaction in JEE Mains as well advanced. Now this reaction is used to prepare, 1 degree amine effectively. So basically in this reaction we prepare a 1 degree amine. What is 1 degree amine? Which has a free nitrogen attached to 2 hydrogen, and there can be a alkyl group over here. Okay. So what happens in this reaction is we take a molecule known as phthalimide. Now phthalimide is basically prepared through phthalic acid. We know that in the previous lecture we had studied about the dicarboxylic acid, and I have also given you the shortcut way of remembering the dicarboxylic acid. So basically what we do over here is we react this with ammonia, right. So basically we know that because ammonia is a base, okay, because ammonia is a base, so it will undergo acid base reaction and form a salt over here. Okay, we further heat it. We know that on heating it will form an amide, water will be released out. This also we have done in the yesterday's class. Then we further heat this, water would be eliminated out again, like H2O will be eliminated from here, and we will form a phthalimide. Okay. Now phthalimide is a very important compound. Okay, if you look at the structure of phthalimide, we can clearly say that these hydrogens are acidic in nature, because once they are abstracted, negative charge would be formed on nitrogen. So this hydrogen is already attached to electronegative atom. So whenever a hydrogen is attached to electronegative atom, it has a acidic strength. So this is having acidic strength. Once it is deprotonated, a negative charge would be formed on nitrogen that would undergo resonance with both the C double bond O, and hence the stabilization of negative charge would take place. So this hydrogen is basically a acidic in nature. Okay. So just remember the nomenclature. RC double bond O NH2, this group is called as amide. Okay. C double bond O NH C double bond O. Now this bond is called as imide. Okay. So if you look in this molecule, so basically this is NH C double bond O, C double bond O. So this is a imide functional group. Now that is why this name comes as phthalimide. Okay. So what happens in this reaction is we take a phthalimide. Now we have already come to know that its hydrogen is acidic in nature. So that acidic hydrogen is abstracted first with the help of a base. So basically we add KOH or any base that is strong enough to pull out the acidic hydrogen from the phthalimide molecule. So we are going to prepare this anion. Now once this anion is created, we know that it is stabilized through resonance. There are two electron withdrawing groups that are attached to the nitrogen, hence this negative charge is stabilized. Therefore, it can act as a nucleophile. Okay, I have already said that once the electron density is increasing, then that particular ion can behave as a strong base. But when the negative charge is getting dispersed or it is getting stabilized, then its nucleophilic character is enhanced. So basically because this is stabilized, so we will say that this is a weak conjugate base. Because it has a negative charge, so it can obviously act as a good nucleophile. So this will go and attack at this carbon bearing the halogen. The halogen will leave out as a halide ion. So in this reaction we are going to form this as the product. Okay. So basically if you look at this, the nucleophile attacks at the carbon bearing the leaving group. So basically this is a SN2 mechanism. Now remember, SN2 mechanism is best for the methyl halide. So basically if R is CH3, this reaction would be fastest because methyl exerts very poor steric repulsion to the nucleophile. So basically for SN2 we say that R should be either methyl 1 degree, with 2 degree there will be substantial amount of E2 product as well. Okay, but we can prepare 2 degree also. But if you take R, if it is 3 degree, now we know that 3 degree alkyl halide does not undergo SN2 mechanism. So basically this would not undergo substitution reaction and it can cause E2 elimination. Okay, so this point we have to keep in mind. Direct questions come on this topic. Okay, so in the last step what we do is we can hydrolyze this through a base. So this basically OH negative goes and attack at this carbonyl carbon. Okay, this pi electron is polarized, which further pushes the electron and the CN bond is broken. So we basically form, in the first step we form, there will be a OH and there will be a negative charge on nitrogen. Okay, so this OH will leave from here and come to this nitrogen because it is basic in nature. Now we can similarly treat it again with OH negative. So this OH negative can go and attack at the carbonyl carbon. This pi electron will be polarized. Now once this pi electron is polarized, it will push out the CN sigma electrons and RNH would come out as RNH negative. Now because we are forming a carboxylic acid and the RNH negative, okay, because it is basic in nature, it will abstract the hydrogen and we will form this as the amine. Okay, so we are going to form a 1 degree amine in that case. Okay, so I hope this is clear to everyone. This is a very important reaction and a very important mechanism. So we are going to form a 1 degree amine. Okay, now this reaction can also be carried out by addition of hydrazine. So what will hydrazine do? Hydrazine will basically, one nitrogen will attack at this carbon and the other nitrogen will attack at this carbon, forming a 6-membered cyclic ring and RNH2 would come out. So basically in a phthalimide reaction, we take phthalimide, we treat it with a base, and in the second step we add any alkyl group containing a leaving group like a halide ion. Okay, so we take any alkyl halide, it undergoes a SN2 mechanism, it forms a N-substituted imide which undergoes hydrolysis to give us 1 degree amine, or we can also react with this with a hydrazine and we'll get a 1 degree amine. Okay, So I hope this reaction is clear to everyone. Just have a quick look. So basically this is how phthalamides are prepared. Then phthalimide is treated with base, an ion is formed which attacks on the alkyl halide via SN2 mechanism and forms a N substituted imide, which on hydrolysis gives us 1 degree amine. Or you can also take as hydrazine. Hydrazine will attack at this carbonyl carbon, other nitrogen will attack at this carbonyl carbon, and Rn group will leave out in the form of RNH2. Okay, so I hope this mechanism is clear to everyone. This is actually very important reaction. Okay, so based on this, let's try to do some question. Okay, now a question that can be framed on this is, which of the amines can be prepared by Gabriel phthalimide reaction. Okay, so I am just abbreviating is Gabriel phthalimide reaction, GPR. Okay, so this is basically Gabriel phthalimide reaction. Now the options can be methylamine, second is isopropylamine, third would be aniline, fourth suppose it is this as a 1 degree amine, fifth suppose is given to us is this amine, sixth suppose given to us is this amine, and seventh suppose it is given to us as this amine, and suppose we are having a 3 degree amine. Okay, so just check which amines can be prepared through this reaction. We know that this reaction is effectively used to prepare a 1 degree amine. So this is a 1 degree amine, so this can be prepared effectively. The reagent that would be required over here is, okay, so basically nitrogen is coming from the phthalimide ring. So we have to basically take a CH3X. So in the first step we will add KOH, second step CH3X, and in third step again we will do hydrolysis, or you can do the reaction with hydrazine. Okay, so this can be prepared. This can also be prepared. Okay, so because this is again a 1 degree amine, so basically we will be getting a phthalimide, we would add KOH, in second step we will add isopropyl halide, and the third step we will do the hydrolysis. So this hydrogen is abstracted in the first step, this attack at this, X leaves out, and then hydrolysis. Okay, now let us look at aniline. To prepare aniline, we have to take phthalimide, we will have to add KOH, and in the next step we have to add a halobenzene or a phenyl halide, and we have to do a hydrolysis. Now we know that any halobenzene is unreactive to a SN2 reaction because of resonance of the lone pair with the benzene ring. The CX bond acquires a double bond character, due to which this bond becomes strong. Now because this bond has become strong, it cannot be cleaved in a normal nucleophilic substitution reaction. Also we say that the nucleophile has to come and attack from the backside. Because there is a benzene ring, the electron density of benzene ring will repel the electron density of nucleophile, hence the nucleophile cannot approach the phenyl ring. Okay, so this cannot be prepared, even though it is a 1 degree amine, but it cannot be prepared because in general halobenzene do not undergo substitution reaction. Now let us look at this. Okay, this nitrogen is 3 degree, but when we try to do a Gabriel phthalimide reaction, so in the first step we have to add KOH, this nitrogen would obviously be coming from the ring. So in the second step we have to add this 3 degree alkyl halide. Now we know that 3 degree alkyl halide also does not undergo substitution reaction, so this cannot be prepared either. Okay, so these are very important conclusion that you should understand. These questions can definitely come in your JEE. Okay, now this can be prepared because this nitrogen is 1 degree, so we have to take basically ethyl chloride. just the way we are preparing methylamine. Now this is a 2-degree amine, right? Because nitrogen has 2 alkyl groups attached to it, and through this reaction we cannot have a 2-degree amine, because obviously this nitrogen is being taken away by the alkyl halide group, so obviously it will be converted into RNH2. So if you take a R group over here, then this will not have a acidic hydrogen, so the reaction won't proceed there. So 2-degree amine cannot be prepared by this reaction. Okay. Similarly, this is the 3-degree amine. 3-degree amine can also not prepared by this Gabriel phthalimide reaction. Now let us look at this molecule. Now this is a very good example. Now to prepare this molecule, we have, along with phthalimide, we have to take this as the alkyl halide, okay, because it is a NO2 at the para position. Now we know that whenever a halobenzene has electron withdrawing group at either at ortho or para position, okay, it can undergo a SN2 aromatic reaction or SNAR, nucleophilic aromatic substitution. Just remember this, we have done in aryl halide chapter. We have said that phenyl halides do not undergo normal substitution reaction. However, when electron withdrawing groups, powerful electron withdrawing groups are attached at ortho and para position, they will withdraw the electron density from the benzene ring, decrease the electron density on the benzene ring, so that the nucleophile can attack easily. So this can be formed through a SNAR mechanism. Okay, I hope you have gone through all the lectures now. SNAR reaction we have already done. Okay, so basically 1, 2, 3 and 4. So these 4 molecules can be prepared through a Gabriel phthalimide reaction. So just one important point you should know over here is, we can prepare only a 1-degree amine, okay, and that 1-degree nitrogen, okay, should have a either a 1-degree methyl group or a 2-degree group or a ethyl group. If a 3-degree group is present adjacent to the nitrogen, then that cannot be prepared. Similarly, we cannot also prepare neopentyl, okay, neopentyl. To prepare this compound we have to take neopentyl halide, okay. So we have to take a neopentyl halide, and we know that SN2 reaction of neopentyl halide is very poor, so this cannot be prepared efficiently even though it is a 1-degree amine. So such beautiful crafted questions on mechanism can come. So for this you need to understand the detailed mechanism, and again the fundamental, as I already told you, goes to substitution reaction, okay. So I hope this example is clear to everyone. Next is from Grignard reagent. Okay, to prepare from Grignard reagent, we basically take any RMGX and we heat it with ClNH2. Now because Cl is a good leaving group, so there is a negative charge on this, so the Cl will leave out and we will form RNH2 plus MgXCl. Okay, so this is a basic preparation from Grignard reagent. From alcohols, to prepare from alcohol we take ROH, to this we add ammonia in presence of Al2O3 and we heat it. So basically Al will go and coordinate with oxygen and convert it into a good leaving group, and then ammonia would attack on the carbon bearing the good leaving group, and a 1-degree amine could be formed over here, okay. Now next very important reaction is reduction. Now this is one of the most important reaction. Most of the questions are formed from the reduction, okay. So we can prepare the amines through a reduction, okay. The common reduction reactions are from nitro compounds, okay. So this is actually a very important reaction. So we take any nitro group, to this we add lithium aluminum hydride, and in second step we can do the hydrolysis, so we will get RNH2. So one such reagent could be lithium aluminum hydride, or second reagent could be tin plus HCl or iron plus HCl, anyone will work, okay. Iron plus HCl is a better way, because once FeCl2 is formed after reaction of iron and HCl, it would get hydrolyzed it would hydrolyze back and we'll get HCl back. Okay. Other such reagent could be hydrogen metal, okay, or it could be sodium ethanol. So when you take any of these reagent and you add it to RNO2, we will get a 1 degree amine. But just remember one exceptional behavior of lithium aluminum hydride. When you try to do the reduction of lithium of nitrobenzene using lithium aluminum hydride, we were expecting that an aniline would be formed in this case. But what happens in this is azobenzene ring is formed. Okay, so you have to remember this. With NO2, with aniline, it forms a azobenzene. Okay, similarly, if we are having 2 NO2 in the benzene ring, okay, if we take tin plus HCl, okay, this is a strong reducing agent, so it will reduce both NO2 group into NH2. So in this reaction, both the NO2 are reduced into NH2. Okay. If we want to reduce only one of the NO2 groups, then we can take ammonium hydrogen sulfide or Na2S. These are also called as Zinin reaction. Okay. So one of the group will get reduced. So we are not going to the mechanism of these reaction because obviously these are difficult mechanism to understand. So this is called as a Zinin reaction. Now we can definitely say that Na2S is selectively reducing one of the NO2 group. So suppose we are having this as a system. Okay. Now to this, if we add Na2S, okay, it will reduce one of the NO2. Now which NO2 it will reduce? It reduces the NO2 which is para to that of methyl. So again, mechanism is not important, you just memorize these reactions. Okay, mechanism of these reactions are not important over here. Suppose we are having a molecule something like this. Okay, now to this we are adding Na2S. So it is basically, it will basically reduce NO2 which is ortho to NH2. Okay, so these are the reaction. Simply memorize these reactions. Okay, these are reaction meant to be memorized. Okay, so this is the basic reduction of NO2 group into NH2. Okay, two reactions which we also know over here is when you reduce a NO2 group with zinc and NH4Cl. Okay, so in this case we get a hydroxylamine. Okay, so if you are taking a benzene ring with a NO2 group and you are reacting with this zinc, ammonium chloride and water, so we are going to form NHOH. This is called as Baker-Mulliken. Okay, now we know that this gives test with Tollens reagent. So if you add Tollens reagent over here, we will get NO plus we get a silver mirror test. So this is also called as a Baker-Mulliken test. Okay. So these are important reduction reaction of NO2 group. Similarly, there is one more reaction. If you take RNO2 group, okay, say we are having a benzene ring as well. Okay, so suppose we are having a NO2 group and to this you are adding zinc, methanol and NaOH. Okay, so this will convert this into a azobenzene. Okay, and if you are taking only zinc and NaOH, so we will get a hydrazobenzene. Right, hydrazo means the nitrogen has hydrogen now, the azo group has hydrogen now. So these are the few reduction reaction of NO2 that are very important. Okay, so you can have a snapshot or you can quickly go through all the reactions. Okay. So, next reaction that comes is, next reduction reaction comes is from cyanides and isocyanides. Okay. We can reduce cyanides and isocyanides, okay, and we get amines. So, basically if you take a C triple bond N, just add lithium aluminum hydride LAH. In the second step you have to add water. So, this H negative will go and attack at this carbon, this pi electron would get polarized on nitrogen, and then addition of water, then again a hydride ion would attack on carbon, finally it would form a RCH2 NH2, okay. Or we can say we can add hydrogen metal, okay. So, hydrogen metal will go on and hydrogenate the triple bond. So, HH goes and attack at the carbon and nitrogen. So, H gets attached to carbon and H gets attached to nitrogen. So, initially we get RCH double bond NH, a imine group, then hydrogen will again come on the carbon and nitrogen and form a amine, okay. Also sodium ethanol can be taken in this case, okay. So, if you take a isocyanide RNC, and when we try to carry out these reductions, so we will form a 2-degree amine, okay. So, we will form a 2-degree amine in this case. Even on hydrolysis, okay, if you hydrolyze RNC, we will get RNH2, okay. So, you have to, you can do this reaction through mechanism, okay. The third reaction is reductive amination. Okay. So, if I tell you about the reductive amination, what would happen in this? Take any imine and to this you add NaBH₄CN or lithium aluminum hydride or hydrogen metal. This would convert it into a amine, okay. So, I will get some questions on this also, okay. So, next reaction could be from oxime. If you take any oxime and to this you add lithium aluminum hydride, so basically this gets reduced into a amine, okay. So, I hope you know all these reactions and have memorized these reactions. Similarly, if you take a azide, yes, and to this you add lithium aluminum hydride, okay. So, this will also form a RNH2, okay. So, this is called as reductive amination, okay. So, just have a quick look. I hope you might be remembering these reactions because they are important reducing agent reactions, okay. The fourth important reaction is reduction of amides, okay. So, whenever we reduce a amide, okay, suppose we are taking a amide RC double bond O NH2 and we are reducing this with lithium aluminum hydride. So, what happens? This converts into a primary amine, okay. So, if we take any N substituted amide also, upon addition of lithium aluminum hydride, it would form a amine. So, in this case it would form a 2-degree amine, okay. So, suppose a molecule something like this has been given to you, and suppose to this molecule we are adding lithium aluminum hydride, and in second step we are doing the acidic workup or we are adding the water. So, basically this is a amide group. So, amide group will get reduced into a amine. So, we will get this, and C triple bond N will also get reduced into a amine. So, we will get this, okay. So, I hope this is clear to everyone. So, basically you have to look for the amide group, okay. So, whenever a question has been given to you, just see if a amide group is present there. If a amide group is present there and you are adding lithium aluminum hydride, it would convert into a amine. Okay. So now let us do one question. Suppose we are having a compound something like this. Okay, suppose we are heating this. So what would happen? Now again what is happening over here is we can see there is a carbonyl group in the molecule, okay, and externally in the compound only a nitrogen is present. So basically what would happen, the nitrogen would attack at the carbonyl group. So this is basically an example of nucleophilic addition reaction of nitrogen or nitrogen derivative on the aldehyde and ketone. So remember the conclusion which we draw over there. Whenever you are taking any aldehyde or ketone and you are adding any nitrogen or its derivative, we have to just remove water. So basically just bring the nitrogen near to the carbonyl group, and in the next step just remove water. So basically we are going to form a structure something like this. Okay, I hope this is clear to everyone. Now basically we are forming a imine over here. Now we can carry out a reductive amination of this through NaBH₄CN or lithium aluminum hydride. So this would convert it into a amine. Okay, so this amine would be formed in this case. Okay, so I hope this example is clear to everyone. So next is the few named reaction. Now the named reaction which we have done already on the Monday's class, where we discussed 4 very important reaction. The first being Hofmann bromamide reaction. We have done the detailed mechanism of it, and we have also seen the mechanistic approach of this reaction and the stereochemical changes that can happen in the reaction. Okay, so basically in Hofmann bromide reaction we are taking a amide, we are adding 4 moles of KOH and bromine to this molecule, and we will be getting a step down amine. Now what is step down amine? 1 carbon, like if you consider this molecule, this is having 1 more carbon and this is having 1 less carbon. Okay, so if there are suppose x number of carbon over here, so this will have x minus 1 because this carbon is going out. So we will be getting KBr plus K2CO3 plus water. Okay. The second reaction was SMID rearrangement or SMID reaction. What we are doing in this, we are taking a carboxylic acid and we were heating this with a hydrazoic acid in presence of acid. So in this we are getting again RNH2. The third reaction was a Curtius rearrangement. Okay, if you have not gone through the Monday's lecture, just go through the Monday's lecture. In the later half of the lecture, I have already discussed these reaction with detailed mechanism. If you take any acyl chloride and to this you add NaN3 and again you heat it, so we get RNH2. Similarly, there was one more reaction which is Lawson rearrangement. So in Lawson rearrangement, basically we are having a nitrogen to which a leaving group is attached. So just treat it with OH negative, we were getting RNH2. Okay, so I hope you remember these reactions. Out of these 4 reactions, this is one of the most important reaction that can be asked in mains as well as advanced. Okay. So see, question like this can be formed on this. I hope you have taken a snapshot or written this portion. Okay. So look at the question that can be formed. Okay, suppose we are having, say, this as the So suppose we are having taking KOH and Br2, so we can clearly say there is a amide over here. So we are doing a Hofmann bromide reaction. So this would get converted into, with a loss of 1 carbon, this would get converted into amine. Now there is a nucleophilic addition of amine on the keto group. So we are going to form a imine over here. Now we can do the reductive amination using NaBH₄CN or LAH, and we'll get this as the product. Okay. Okay, so let's come to the reaction of amines. The first reaction which we are going to discuss is HEME reaction. HEME reaction is basically Hofmann exhaustive methylation and elimination reaction, which we have already discussed in elimination reaction, but I will show you one example so that these concepts are revisited. Okay. Suppose we are having a nitrogen. To this, suppose groups like this has been attached. Okay. So the reaction is basically Hofmann exhaustive methylation. So what we have to do in the first step, we have to exhaust the nitrogen and convert it into a quaternary ammonium salt. So we are exhausting it with a methyl group. That's why it is called as exhaustive methylation. Okay. So we are going to form this as the quaternary ammonium salt. Okay. In the next step, we heat this with moist Ag2O. Okay. So this is basically an example of a E2 reaction. Okay. I have already discussed this in detail in a elimination chapter. So this is basically an example of a E2 elimination with the transition state bearing a carbon ion. Okay. So this is example of E2 elimination. In E2 elimination, we know that there is a removal of beta hydrogen and the leaving group. Now this is a special type of E2 reaction because the leaving group is poor. So whenever leaving group is poor, we say that Hofmann products are formed because the transition state resembles carbonyl-like character. In a normal E2 reaction, transition state was resembling a alkene-like character. So if you look at this nitrogen, so this is your alpha, this is your beta hydrogen, this is your alpha, this is your beta. Similarly, this is your alpha, this is your beta. So if you look at the different beta hydrogens, beta 1, beta 2 and beta 3, among these beta hydrogens, we can clearly say that beta 1 will be most acidic because once it is abstracted, the carbon ion that would be formed over here would be more stable, because carbon ion formed over here would be destabilized by the electron releasing effect of methyl because it is a 2-degree amine. Similarly, a beta hydrogen removal would lead to formation of carbon ion over here because there are 2 methyl groups already attached to it. So they will push the electron and destabilize the carbon ion. So basically the transition state will have a carbonyl-like character at beta 1 position. Okay. Then what would happen? This should push its electron and this would go out. So basically we will get this as the product. Okay. So we will say that this is example of a E2 elimination with Hofmann product as the major product. Okay, so Hofmann product is the major product over here. For all those who have joined later, so you can just go on the initial 3 lectures. The first lecture was based on Grignard reagent, second was substitution, third was elimination. So for 4 days we studied these reaction mechanisms only, and they are actually very important because they will they are coming up in every chapters. Okay. So the next reaction is acylation. Okay. Now we have already done this reaction in alcohols. We say that whenever a alcohol is reacted with a acyl group, either a acyl chloride or acidic anhydride, we say that this oxygen will attack at the carbon, Cl negative would go out. So basically we would form a ester molecule over here. Okay. Now this reaction is also carried out in presence of pyridine. Okay. Pyridine over here does 2 things. First it neutralizes the acid that is formed, because we know that the ester can undergo acid hydrolysis and it can give back, it can revert back to the alcohol and the acyl chloride. So basically pyridine will neutralize the HCl. Also what happens is initially the pyridine attacks, because Cl, if you look at Cl is neither a very good leaving group, neither a very bad leaving group. So it is a borderline case. So this is actually taken out to be a leaving group which comes out slowly. So basically this nitrogen will attack on the carbonyl carbon. So this would polarize, we would get O negative, we will get a positive charge on nitrogen. This negative will push out the Cl and we will get nitrogen having positive charge is a better leaving group than Cl. So this is formed. Now then the alcohol can attack and can form ester. So basically pyridine is doing two things. It is neutralizing the HCl that is coming out. Also it is replacing the Cl with a much better leaving group. Okay. So we already know that in this reaction a hydrogen is replaced by C double bond O CH3. So when this is replaced by hydrogen, okay, so there is an increase in mass by 42 units. Okay, so I have already done a question on this. A question can come, suppose the alcohol is having a mass of say 370. Okay, on acylation its molar mass becomes say 480. Okay, find the number of OH group formed. So the initial mass was 370. Upon acylation it becomes 480. That means there was a increase of, oh sorry, initial suppose the mass was 370 and it became say 580. Okay, upon acylation it becomes 580. So there was an increase of mass of 210. Now we know that when one C double bond CH3 is incorporated, the molar mass would increase by 42. Because there is an increase of 210, the molar mass is increased by 210 units. So basically there would have been 5 such groups that have been incorporated. Because 5 groups have been incorporated indicates that there are 5 OH groups that will be present in the molecule. Okay. Now similar reaction can happen with amines also. So if you take acyl chloride, okay, you take pyridine. So basically this will attack and will form this molecule, okay, plus HCl. Okay, the role of pyridine is same. Okay, so if you carry out the benzylation through this method, this is having a name which is called as Schotten-Baumann reaction. Okay, so that is called as a Schotten-Baumann reaction. Okay, so in this reaction we carry out benzylation. Benzylation means you are taking RNH2 and you are adding benzoyl chloride. Okay, and you are adding pyridine along with it. So nitrogen will go and attack at the carbon, Cl will leave and finally HCl would depart. So basically we are going to form this. So this reaction is basically benzylation and hence is called as a Schotten-Baumann reaction. Okay. Okay, so this is called as a benzylation or a Schotten-Baumann reaction. Okay, so I hope this example is clear to you. We have already done this reaction in alcohol chapter, so just an application of that reaction. Okay. Next that comes in is the action of HNO2. Now this is a very important reaction because this reaction is apparently both in aliphatic as well as aromatic amines. So let's look at this reaction now. Suppose we are having any RNH2 group and to this we are adding NaNO2 and HCl. So basically NaNO2 HCl mixture or HNO2 produces NO plus nitronium ion. The nitrogen lone pair attacks on the nitronium ion, okay, and then after successive elimination of water it converts into a diazonium salt, diazonium species. Okay. Now once this is formed, this can come out, okay, and the water can attack on the carbocation and form a alcohol. Now remember I told you that if R is a methyl or a 1 degree group, then SN1 reactions are not favored because the carbocation is not stable. But if you look at this Rn2 plus, N2 plus is one of the most powerful leaving groups, because when it comes out you can see it is N triple bond end. So it is highly inert bond, highly stable bond, having very high bond energy. So when it comes out as a gas, the gas escapes from the mixture and also it releases a lot of energy because a strong bond is getting eliminated out. Okay, a stable bond is getting eliminated out. So due to this, N2 plus will leave and a carbocation will be formed in these reactions. So whenever N2 plus is the leaving group, carbocation will be formed. So carbocation is formed, water can attack and form a alcohol. Okay, some amount of alkene will also get as the minor product. Okay, but believe me, JEE never asks much of detail of reactions, those are not mentioned in the syllabus. Okay, so there is one important reaction which is, if we are having it in the NH2 in a ring system. Okay, so if you react with HNO2, so this will basically convert into a N2 plus. Okay, so this will leave out, so a carbocation is formed. Now we know that a carbocation just outside a ring, okay, faces a ring expansion. So basically this ring would expand and water would attack and form a OH. Okay. Now there is one very important aspect, we have done a ring expansion over here. Okay. Now there can be a ring compression as well. So if we look at this structure again, so suppose we just compress this ring. Now what do we mean by compressing this ring? We just push this sigma electrons to this carbon. So what will happen over here is, okay, just let me correct it now. Now if we compress this ring, so we will be forming species, no, because this is having, no, like, it's already having 5 carbon. Okay, so there is no issue in this. Okay, so this will be the product. Now this is called as a Damjanov rearrangement. Okay, so just write it down, I will do the ring compression case. Okay, so this is called as Damjanov rearrangement. Okay. So whenever you are taking a 1 degree alcohol and you are reacting with HNO2 or NaNO2 HCl, will form a alcohol. Okay. So suppose we are having this as the case. Okay, now we are treating this with HNO2. So HNO2 will basically convert this into N2 plus. Now this will come out. So a carbocation will be formed. Now we know that this is a very highly stable carbocation. Okay, because of the dancing resonance or the tau bonds or the bent p orbital concepts. Okay, so this can be attacked by water and form a alcohol, something like this. Now this can also undergo ring expansion because there is a positive charge just outside the ring, and that carbon is not the part of the ring, so this will undergo expansion. So when it undergoes expansion, it will form this carbocation, water can attack and will form this. So out of these two products, if you look at the thermodynamic stability of the ring, we know that the 4-membered ring is more stable than the 3-membered ring, but because in this reaction the mechanism is undergoing through a carbocation formation, so basically this carbocation is more stable. So we will say that this product is formed in a little more amount. So if you look at, this is roughly 62% and this is basically 40 to 38%. Okay. Similarly, there can be a ring compression as well. The case for that would be, suppose we are having this as the amine and we are treating it with HNO2. So this would basically convert this into a N2 plus. Now this can go out, a carbon formed. Now in this case there would be a compression. So the ring compression would lead to a formation of a stable carbocation and then this would react with water and form a alcohol. Okay, so this would be the major product. So we are saying that whenever we are reacting a 1 degree amine with HNO2, Okay, so basically we will be forming we will remove NH2 as N2 plus, which will depart as N2 gas. A carbocation will be formed. Now that carbocation can undergo rearrangement, ring expansion, and finally it will be attacked by water and it will give us a alcohol product. Okay, elimination product. Alkene would definitely compete with it, because we know that whenever there is a possibility of SN1 reaction, there is a minor amount of even product that is also formed. Now if you react with a 2-degree amine, so we are talking about a aliphatic 2-degree amine. So basically a 2-degree amine will be like this. Now when you react this with HNO2 or NaNO2HCl, we will be forming, this is called as nitrosoamine. So this is basically a yellow oily liquid. So basically with 1-degree amine, alcohols are formed. With 2-degree amine, yellow oily nitrosamine is formed. Now if you take a 3-degree amine, 3-degree amine basically does not have hydrogen attached to nitrogen. So when you react this with HNO2, so it will form a quaternary salt. Okay, so it can form a quaternary salt. Okay, so these are the quaternary that can be salt. So this is the reaction of aliphatic amine. 1-degree aliphatic amine on treatment with HNO2 gives a carbocation which is attacked by water and alcohol are formed. 2-degree amine gives us nitrosamine. 3-degree amine forms a quaternary ammonium salt. Okay. Now if we look at the action of HNO2 on aniline. So basically if you take aniline and to this you add NaNA2HCl. So basically we know that we will form a benzene disonium chloride. Okay, so a 1-degree aromatic amine gives us benzene disonium salt. If we are taking a 2-degree amine, okay, if we are taking a 2-degree aromatic amine and we are reacting this with NaNO2HCl, so it will again form a nitrosamine. So basically what is happening, HNO2 is giving out NO plus, nitrogen is attacking on NO plus, okay, and then removal of successive water gives us disonium chloride. But once a NO is attacked by nitrogen at 2-degree amine, there are no hydrogen left. So basically it cannot undergo any further elimination of water to form disonium salt. So we form yellow oily nitrosamine. Okay, so I hope these reactions are clear to you. Now if you take a 3-degree amine, 3-degree aliphatic was forming a 3-degree aliphatic was forming a quaternary salt, but if you take a 3-degree aromatic amine, so in this case what would happen, NO plus would come out, and because nitrogen is a strong electron releasing group and an activating group, so this will activate the benzene ring for the ES reaction. Okay, and the NO would go and occupy the para position. So basically a ES reaction would occur in this. Okay, so basically a aliphatic 1-degree amine gives alcohol, aliphatic 2-degree amine gives a yellow oily liquid nitrosamine, aliphatic 3-degree amine gives us a quaternary salt, aromatic amine like aniline gives us benzene disonium salt, 2-degree aromatic amine gives us yellow oily nitrosamine, 3-degree aromatic amine gives us a EAS product. Because NO plus is formed, benzene ring is activated, so NO will go and attack at the benzene ring. Okay. So now let's just come to the reactions of disonium salt. Okay. So suppose you are having a disonium chloride. Okay, so let's write it differently. So suppose we are having a benzene disonium chloride. Okay, so I hope everyone might be knowing these reactions because they are also very important reactions used in conversion questions. Okay, that are often asked in board also. So these reactions you might have studied in board as well. Okay, so you take any disonium chloride, to this you add CuCl and HCl. Okay, so we are going to get a chlorobenzene. Okay, if you take CuBr HBr, Okay, so we are going to get bromobenzene. If you are taking CuCN and HCN, we are going to get cyanobenzene. So these reactions are called as Sandmeyer reaction. Okay. So I hope you remember these reactions. When you heat this with HbF4, so HbF4 basically forms N2 plus BF4 negative. When you further heat this, we get a fluorobenzene. Okay. Now this is again the named reaction known as Balch-Schiemann reaction. Okay. So I hope you remember all these reactions. Similarly, if you react this with Ki and heat it, so we get iodobenzene. These are also known as Gatermann reaction. Okay. Similarly, you take this molecule and take copper HX. Okay. So we get a X. So these are called as Gatermann. Okay. Now take water and boil with water. So when you boil with water, you will get phenol. Okay. Now this is basically a example of SNA. This is basically example of SN1 type of reaction. N2 plus will go out, a carbocation will be formed, and water will attack. Now basically Sandmeyer reaction follows radical mechanism. The mechanisms are not at all important for JEE. This is just for your own idea or your own confidence. Okay. So when you heat this with H3PO2 or ethanol, heat this with H3PO2 or ethanol, we will get a benzene ring. Okay. Now when you react this with SnCl2HCl, so we get phenylhydrazine. Okay. Now when we react this with phenol in a alkaline medium, suppose we are taking pH as 9 to 10, we are reacting with this phenol, so we will get a azo dye. We have already covered this as well. We get a red orange azo dye. Okay, so we basically get a red orange color azo dye. Okay, similarly if you react this with aniline or a N substituted aniline, okay, so we'll get a methyl orange molecule. Now this came in this JEE Mains examination as well, right? This question came. So basically it was saying that benzene disodium chloride is reacted with a NN dimethyl aniline. The product formed is methyl orange, which is used as a indicator in a strong acid base titration, okay, or a strong base weak acid titration. So this is the basic reaction of benzene disodium chloride. So just have a quick look. I hope you remember all these reactions. Okay. I hope you have taken a snapshot or have written it quickly. The next important reaction is a carbylamine test. Okay. So carbylamine test is basically used to test a 1 degree amine. Okay. So we can test a 1 degree amine. So 1 degree amine can be any that is having NH2 group. So there is no other requirement. It has to be a 1 degree amine only. So all these molecules will undergo a, because the nitrogen are 1 degree to it. So all these molecules will undergo carbylamine test. Okay. So basically a 2 degree amine will not give, or a 3 degree amine will not give this test. Rest all the 1 degree amines give this test. So what happens in this reaction? We take RNH2 and we treat this with chloroform in presence of a base. Okay. So in this case we get RNC isocyanide Okay, now this isocyanide is foul smelling. Okay, so basically we identify this with a foul smelling. This is highly poisonous also. So remember, there was a Bhopal gas tragedy in which methyl isocyanide was released. So again it was very poisonous, that caused the death of many people. Okay, so basically NH2 is converted into RNC, we get isocyanide. So this is called as a carbylamine test. Okay, the next reaction is reaction with sulfonyl chloride. Okay, so if you take say a 1 degree nitrogen and you react with suppose a sulfonyl chloride, this can be an alkyl, this can be an aryl. So these are basically called as Hinsberg reagent. Okay, so modern modification of Hinsberg reagent is a methyl is attached at the para position. So if a methyl is not attached, it is also referred as a Hinsberg reagent. So basically this nitrogen will attack at the sulfur. Okay, pi electron will get polarized, the negative charge will push out the Cl negative and eventually the HCl would be lost. So we are going to form RNH, H double bond O and a benzene ring. Okay, similarly if you take a 2 degree amine, so this is basically a 1 degree amine. So you take a 2 degree amine. Okay, so the 2 degree amine will also go and attack at the sulfonyl chloride. Okay, so this will go and attack and again HCl will be eliminated out. So we are going to form this. Okay, so if you look in this reaction, so the presence of hydrogen with a nitrogen is important because this is attacking. Nitrogen will have a positive charge, O negative will push the Cl negative, which will take up the H from the nitrogen, so that nitrogen becomes neutral again. So if you take a 3 degree amine, okay, now 3 degree amine does not have any hydrogen attached to nitrogen, so this would basically not react at all. Okay, so I hope this is also clear to everyone. Now because there is still a hydrogen left, okay, so this can dissolve in base because this is acidic. The H plus abstracted will give a nitrogen a negative charge that can undergo resonance with the S double bond O. So basically if you add this into a base, this will dissolve. Okay, if you add this in a base, this does not have any hydrogen, so this would not dissolve. So basically this is also, Hinsberg reagent is also used to differentiate 1 degree, 2 degree and 3 degree amine. So basically what you are doing in this reaction, basically we are eliminating HCl. Okay, so in this HCl will be eliminated, in this HCl will be eliminated, in this HCl cannot be eliminated because there is no H attached to nitrogen. Okay, so Hinsberg reagent is used to differentiate a 1 degree amine, 2 degree amine and a 3 degree amine. 1 degree amine reacts with Hinsberg reagent and then dissolves in a base, whereas 2 degree amine reacts with the Hinsberg reagent but does not dissolve in a base. So that will differentiate between 1 degree and 2 degree. 3 degree amine will not react with Hinsberg reagent, so that will differentiate the 3 degree amine. Okay, next very important reaction is the Hoffman mustard gas reaction. Again this is also test of 1 degree amine. Okay, so this is also the test of 1 degree amine. So basically when you take a 1 degree amine and you react this with carbon disulfide, so this will basically go and attack at the carbon, okay, and polarize the sulfur bond. So we will get something like this. Okay, now when you react this with HgCl2, so basically Hg will take out sulfur and it will form RNCS plus HgS. Now this smells like mustard gas. Okay, because this smells like a mustard gas, so we say that this is a mustard gas reaction. So this is a test which is given by a 1 degree amine, because if you take a 2 degree amine, so all 1 degree amine will give a mustard gas like smell. Even if you take aniline, so with aniline you have to just remember that you have to take 2 moles of aniline, and when you react this with carbon disulfide, so just remove this, so we are going to form something like this is formed, and now when you react this with HgCl2, so we get, okay, so this is again a mustard gas smell. If you react with a 2 degree amine, okay, we cannot get the mustard gas smell. So if you react this with a 2-degree amine, so basically a 2-degree amine will form something like this, okay. So it does not have a hydrogen to attach to nitrogen, so it cannot form a mustard gas, okay. So this again is a test for 1-degree amine. Next important reaction is oxidation, okay. So if we do the oxidation of a 1-degree amine, so basically oxidation of amine means first if we are oxidizing, we can convert it into a hydroxyl amine, further oxidation will convert it into a NO group, and further oxidation can convert into a NO2 group, okay. So when you are doing a oxidation of a 1-degree amine by KMnO4, so KMnO4 what it does, this will oxidize, okay, we'll get this imine on hydrolysis will give us aldehyde. So basically we get aldehyde, okay. Similarly, you can do for any 1-degree amine. Just remember that whenever a 3-degree nitrogen, 3-degree carbon is connected to a 1-degree amine and you do a oxidation using KMnO4, so in this case we directly get a NO2 group. For 2-degree amine, okay, if you take a 2-degree amine, so a 2-degree amine is something like this. Now when you react this with KMnO4, so it forms this, okay. So tetraalkyl substituted nitrogen we get. With 3-degree amine, okay, 3-degree amine is the one in which you react with H2SO5 or H2O2, it gets converted into a N oxide. So we get a N oxide over here, okay. So I hope these reactions are clear to you. So this is basically the oxidation of amine. Now if you look at the oxidation of aniline, so if you take aniline in air, just like phenol, it oxidizes in presence of K2CR2O7 into a benzoquinone, which can further complex with NH2 and form a black tar, okay. So basically if you are having aniline or you are having a phenol, okay, on oxidation they give benzoquinone, or if you are having both the groups in the same ring, okay, suppose we are having NH2 and OH, this will also get oxidized into a benzoquinone, okay. So I hope this is clear to everyone. Okay, test of amines already we have done. Aniline, I just wanted to discuss one reaction, okay. So if you take aniline and to this you add bromine water. Now nitrogen is again a very powerful activating group, so it will activate all the positions of ortho, all the ortho and para position to such an extent that bromine would get attached at all the position, okay. So this just you have to remember this. So if there are any COOH or SO3H group at ortho or para position, they will also get eliminated out and will get a tri-substituted product, okay. Now when you react this with bromine in presence of carbon disulfide, say temperature is 5 degrees Celsius. In this case also we get a tri-substitute product only, okay. We don't get a mono-substitute product because NH2 is a very activating group. So to get a mono-substitute product, what we need to do is we need to react aniline with the acyl chloride group. Now once it reacts with acyl chloride group, it get converted into a acetanilide, okay. Now this acetanilide is a moderately activating group because initially what was happening, nitrogen was giving only electron in the benzene ring. Now there is a competitive side with C double bond O as well as benzene. So it can give electron over here, it can also give electron over here. So the electron coming in the benzene ring would decrease. So basically it would become a moderately activating group. So when you add bromine now, because the activating power of nitrogen has decreased, so only ortho or para substitute product will be formed. Para will be major in that case. And once you hydrolyze this, we'll get back the amine. Okay, so I hope this is clear to everyone. Okay, so this is again a very important reaction that can be asked. Last reaction which I wanted to discuss before I will open the session for Q&A. If you have any doubts, just write your doubts in the chat box. So when we react it in a nitration reaction, okay. So in this case, we get 2% ortho product, 51% para product. Okay, NH2 is a ortho para dating group, so we were expecting the ortho and para product to dominate. But if you look in this reaction, a considerable amount of meta product is also formed, that is 47%. Now, why does this happen? Because we have maintained acidic medium. So in acidic medium, NH2 can get protonated and change into NH3 plus. So you will get anilinium ion because you are taking NH2 aniline in a basic medium. So this will get protonated, and we know that anilinium ion is a meta directing group, so it will direct the electrophile at the meta position. Okay, but still the major product is para 1. Okay, but if the nitrogen is substituted, if there is even a single substitution, okay, now when you are doing this HNO3 and H2SO4, we know that this will get converted into a positive nitrogen. So in this case, meta will be the major product. Okay, similarly, if you take a 3-degree nitrogen and you are taking HNO3 H2SO4, in that case again meta would be the major product. Okay, so I hope I have covered almost all the reactions of amines and aniline. You just go through the classroom lecture, and if you are having some particular notes, you can go through those notes. You can just read your NCERT for better understanding. Like the most important reactions are in this chapter is reductive amination, carbylamine test, action of HNO2, aniline, reaction of aniline, and benzene diazonium chloride reaction. So these are the few very important reactions. Definite questions can be asked from these topics. Okay, so this is it for today. I open the this Q&A session, question and answer session. If you are having any doubts, any problem, just write to that in the chat box. I will take it right away. Let us take up the doubt. Okay, the first doubt is, now Varun, you have you have given this question in a pattern that I have to look like this. Okay, so this is basically, okay, so what I can make out from here is, okay, I will get back to your question. I missed it out. I will get back to your question. Now this is the question that has been posted by Gurudeep. Okay, so this is basically, the first reaction is basically dehydration reaction. So basically we'll remove the water, we'll get C triple bond N. Now when we react with this Grignard reagent, we get, again we have done this in Grignard reagent, we'll get a ketone. Now because there is a methyl ketone, on reaction with calcium hydroxide and iodine, okay, we'll get a iodoform. Okay, so we get CHI3, okay, and we get C double bond O negative. Now because this is a carboxylate ion, now this carboxylate ion will get attached to calcium through ionic bond. Now there has to be 2 carboxylate ion because the valency of calcium is 2. Okay, so basically first you are forming a cyanide, nitrile, then a ketone, then a methyl ketone undergoes haloform reaction and it forms this as the product because it is having negative charge and calcium is having 2 positive charge. Now when you heat this, so basically this is heating of calcium carbonate comes out, and when the calcium carbonate comes out, we will get this as the ketone. Okay, so I hope you have understood this, Gurudeep. Okay, so next question is, two isomeric ketones, 3-pentanone and 2-pentanone can be distinguished by. Okay, so basically we are having 3-pentanone. Okay, so this is 1, 2, 3, 4, 5. This is 3-pentanone, and then we are having 2-pentanone. So this is basically, so one is methyl ketone, okay, and the other is a normal ketone. Okay, so toluene is not the answer. Toluene gives test with aldehydes. Phenylhydrazine, again both will react with phenylhydrazine. Aqueous NaHCO3 is the right answer because this methyl ketone reacts with aqueous NaHCO3 and it will give a crystalline substance. This will not give. I think in your answer key, I think bleaching powder is giving. Bleaching powder is not the right answer. Bleaching powder is a, like if you are asking about bleaching powder, so basically it is CaOCl2. If suppose like someone is saying that okay, this is also calcium hydroxide and chlorine, this is incorrect. Or in bleaching powder we are having CaOCl. Okay, CaOCl basically means that we can also carry out a haloform reaction. Now when you carry a haloform reaction with Cl, so we'll get CHCl3 in this case. Okay, CHCl3 does not have any color, so they will not be able to differentiate between these two compounds. Have it been a say a calcium hydroxide and iodine or NaOI, then it would have been a haloform reaction. This molecule would have given a haloform reaction. CHI3 is having a yellow color, so we would get a yellow color, and then we can differentiate from this. Okay, so basically if we are talking about distinguishing two compounds, so it has to be through a chemical test, so through a visible color change. So basically NaHCO3 would give a crystalline substance with this, and this would not give any crystalline substance with this. But when you take in bleaching powder, so basically this would give chloroform. Chloroform does not have any color, so this will react but this won't react, but there won't be any differentiation test because there is no visual color change, okay, or any gas evolution. Okay, so A is the correct answer only. Okay, the next question please. Total number of acids and ester possible for C4H8O2. Okay, so basically if you look at C4H8O2, so basically we are having 4 carbons. So the acid that can be formed is this. So this is 3, 2, 5, 7, 8. So we can do a branching over here. So branching can form this as the carboxylic acid. So there are only 2 type of carboxylic acid that is possible over here. Okay, and esters. Okay, for esters we can say that the first ester that we can have is this. Okay, CH3CH2. Okay, the second ester which can we have is CH3C double bond O, OC2H5. Okay, the third ester we can take this over there also, so we will form a ester. Okay, now because there are 3 carbons over here, so we can do a branching over here. So the fourth possibility is the formation of this ester. Okay, so there are total 2 carboxylic acid and 4 ester that can be formed in this case. Okay, so total isomer would be 6. Okay, let me come to the first question. The first question which you showed me. Okay, the first question that you showed me, that was in the vertical panel. Okay, so there was one question that is left. I will get back to that question tomorrow since we are running short of the time. So basically I will just see the question, okay, because that was in a like vertical mode, so I could not see it properly. So okay, so I hope you are preparing the topics well and you are now going through the chapters. Probably by the end of this week we are going to end the entire organic chemistry. So we took almost 3 weeks to complete the revision or the crash course of organic chemistry. So just go through the individual reaction mechanism properly, read NCERT properly line by line, memorize important physical property, colors and their uses which are often asked in JEE Mains. Okay, so by the end of this week I hope you are also able to complete organic chemistry with a lot of confidence. Okay, so this is Animesh signing off for now. Tomorrow we'll catch up with more interesting session on biomolecules.